Math 102, Example 1.1.2, version A. Now, when we have radicals, sometimes we get perfect squares, but sometimes they aren't perfect squares. That doesn't mean we can't do anything to it, though. So, for example, the square root of 24, are there any perfect squares that multiply up to 24? And 24 is 4 times 6. 4 is perfect square, so I'm just going to rewrite it as 4 times 6. Now, if we have multiplication like that, we can rewrite that as root 4 times root 6. And then what is the square root of 4? It's 2. Now, there's no perfect squares that multiply up to 6. 2 and 3 go into 6, but those aren't perfect squares. So 6 can't be simplified, so that is our fully simplified radical. Now, for the square root of 200, there's lots of perfect squares that go into 200. 4 and 25 both go in, but I would like to find the biggest perfect square. So here, the biggest perfect square that goes into 200 is 100. So let's rewrite that as 100 times 2. So once again, I can then rewrite that as root 100 times root 2. The square root of 100 is 10, so let's take that square root. You'll notice I always put the square root, the perfect square, first as a clue to myself that that is the number that is going to be simplified. The square root of 2, no perfect squares go into 2, so that is my final answer.